So good evening all of you. So in this lecture, we will continue with the topic of electric dipole. So in last lecture, we have defined what is an electric dipole. So if you have 2 point charges that are separated by a very small distance, A tending to 0, and let's say charge Q is very large, Q tends to infinity. So product Q into A will be a finite value, and that defines its dipole moment. And direction of the dipole moment is from minus Q to plus Q charge. So in first case, we have calculated the electric field along the dipole axis. What is the dipole axis? If you connect these 2 point charges by this line, so this is called the dipole axis, and I have taken a point P along the dipole axis, and then we have calculated the field due to dipole along the dipole axis. So you can find field due to plus Q charge, then field due to minus Q charge, take vector sum. Finally, we got this result, 1 by 4 pi epsilon naught 2p by r cube. So in this case, just see electric field dependence is not 1 by r square dependence. It is 1 by r cube dependence. So magnitude is inversely proportional to distance cube. So that is the case of electric field along the dipole axis. So that case we have discussed. Now we will focus on second case. So let's see second case. Second is electric field perpendicular to the second one is for points on the equatorial plane. You have to find electric field for the points on the equatorial plane. So let's see the dipole. This is plus Q charge. And this is the minus Q charge. They are separated by a distance 2a. And its dipole moment is in this direction. This is the direction of the dipole moment. Dipole moment is in this direction, where P is given by magnitude of P is Q into 2a. Now you have to find, let's see, consider some point that is on the equatorial plane. So I am considering let's say this is the center of the dipole, and this point P lies on a plane that is perpendicular to the dipole axis. Equatorial plane is plane perpendicular to the dipole axis. So we have to see what will be resultant field at this point, at any point P that is in the plane perpendicular to the dipole axis. So what you have to do, you have to find field due to plus Q charge and minus Q charge. So at this point, if you see E plus Q, so this is the direction, magnitude and direction of field E plus Q, because this charge is positive. This length is A, and if you take this to be R, take this angle is theta. I am taking just this angle is theta. So what will be magnitude of E due to plus Q charge? So this is given by 1 by 4 pi epsilon naught q by r square. And if you are taking, let's take this distance to be r instead of this to be r. Take, now I am taking, instead of this to be r, take this distance is r. I am taking this distance to be r. So what will be electric field? You have to write this particular distance from this point to this point. So this length is what? Under root r square plus a square. So this will give you r square plus a square. And direction is in this direction, radially outward from plus q charge. Now you have to see field due to minus q charge. So you know field due to minus q charge will be in the direction of minus q, towards minus q. So this is the E minus q. This is E minus q. And because distance is same, so magnitude will be same. Only thing is direction is different. So at this point, you have two fields, two vectors. One is E plus Q, one is E minus Q. So what you have to do? You have to apply the superposition principle. So you have to resolve field in component form and then take vector sum. So just see how you will take the component form. Now see, if this angle is theta, this is also theta. So this angle will be 180 minus 2 theta. So what will be this angle? This is theta and this is also theta, because this will be 180 minus, this will be 180 minus 2 theta. Is it clear? Now let's resolve the vector in component form. Resolve these vectors in component form and find the resultant. Please check. Let's try to calculate. Try to calculate this. So if you resolve this in component form, what will happen? What will be component of plus q in this direction? This component is E plus q cos theta. What is component of E minus q along this direction? This is magnitude of E minus q cos theta. What is component of plus q in this direction? So this will be E plus q sin theta. And what will be component of E minus q in this direction? So this is E minus q magnitude cos theta. Now take vector sum. So let's see if you are if I'm taking this to be x direction, this is y direction. So resultant along y direction will be 0. This component will cancel out. There will resultant in y direction is 0. So resultant in y direction will be 0. And what will be resultant in x direction? Resultant in y direction is 0. And resultant in x direction will be given by, because magnitude of plus q minus q is same. So this is twice mod, I am taking plus q cos theta. And direction will be x cap. This is the direction. So let's write the magnitude. What will be this value? So Ex component is given by 2 times one by 4 pi epsilon naught Q by R square plus A square. And what will be cos theta? Cos theta is A by under root R square plus A square. So this will be given by A by under root R square plus A square. So finally, this will give you 1 by 4 pi epsilon. This is the magnitude I am calculating. 2qa by R square plus A square power 3 by 2. And this will be approximately equal to 1 by 4 pi epsilon naught 2qa by R cube, because I am taking R is far greater than A. You have to take this approximation that this distance will be very small. And this value is P. So finally, if you see the resultant field, just see, this is the direction of the dipole and electric field is in the opposite direction. So we can write this as, I'm writing this to be minus 1 by 4 pi epsilon naught P vector P by R cube. This is the field on the dipole axis in the plane perpendicular to the dipole axis, and direction of field will be opposite to the dipole. In previous case, it was in the direction of the dipole. If you are seeing along the direction of the dipole, field will be in the direction of the dipole moment. But in a plane perpendicular to the dipole axis, field will be in the direction opposite to the dipole moment. So must remember this case, field due to dipole along the dipole axis and in a plane perpendicular to the dipole axis. So at different point, electric field will be different. Clear? So note it down. Clear? So this I have discussed along the direction of the dipole axis and perpendicular to the dipole axis. But if you will see in at graduation level or post graduation level, that at any angle you can find the field due to dipole. Clear? So I will also write the formula if, because you are or the graduate BSc or MSc student, so you can also remember in other way also. So let's see. Just remember the formula, that is I am writing for your PGT exam. So because in graduation and post graduation level we study everything in either mainly in symmetries, spherical symmetry or cylindrical symmetry or Cartesian symmetry. So I am taking this to be X, Y, Z. I will write the only formula. So if you take this to be a dipole along this direction. So in spherical symmetry, we will write, let's see, this point is P here, this angle is theta, and this is R. So I am writing in spherical symmetry. This is R cap, this direction is theta cap. So electric field will be given by 1 by 4 pi epsilon naught. Then you have P by R cube. Now you have 2 cos theta R cap plus sine theta theta cap. So you can this is in spherical polar coordinate. this is in spherical polar coordinate. Spherical polar coordinates. And the case that we have discussed two special case. One is along the dipole axis. So we talked about at this point. So at this point, theta will be 0. So when you put theta is equal to 0, you will get this value 1 by 4 pi epsilon naught 2p cos theta r cap. And in this at this point, this is the r cap. This is the r cap. So at theta, when theta is 0, theta is 0 degree. So electric field is 1 by 4 pi epsilon naught 2p by r cube. So we derive same equation. Now r cap, this direction is in the direction of dipole. And if you are taking this point where theta is, let's say 90 degree. Theta is 90 degree. So in this case, sin 90 is 1. So this field is given by 1 by 4 pi epsilon naught p by r cube. And this is theta cap. And what will be direction of theta cap here? Just see theta cap is downward. So this direction is opposite to P and this direction is P. So we have discussed, we have derived these two cases. But in general, in a spherical symmetry, if you want to write in terms of R and theta, so this is the general expression. So for exam point of view, you must remember this also in a spherical symmetry also. Is it clear? So this has, because in spherical symmetry, it has two component, E theta cap. So this component is ER component and this component is E theta. And this direction is theta cap. And let's see resultant field is, I'm taking, this is the resultant direction of field E. And that makes an angle alpha with R cap. ये R cap के साथ अल्फा एंगल बना रहा है, तो इसका मैग्नीट्यूड क्या होगा? अगर हम स्फेरिकल सिमेट्री में लिखें तो मैग्नीट्यूड विल बी ई आर स्क्वायर ई थीटा स्क्वायर. ठीक है. और यहां से देखो ई आर आप क्या लिख सकते हो? रेडियल कंपोनेंट ये हो जाएगा 1 by 4 pi epsilon naught 2p cos theta by r cube. और ई थीटा कंपोनेंट क्या हो जाएगा? 1 by 4 pi epsilon naught p sin theta by r cube. तो यहां से अगर आपको मैग्नीट्यूड लिखना हो, सो 4 cos स्क्वायर थीटा प्लस साइन स्क्वायर थीटा. साइन स्क्वायर थीटा इज 1 माइनस कॉस स्क्वायर थीटा. तो ये वैल्यू हो जाएगी p by 4 pi epsilon naught r cube अंडर रूट 3 cos स्क्वायर थीटा प्लस 1. ये स्फेरिकल सिमेट्री में हम लिख रहे हैं. और जो रिजल्टेंट डायरेक्शन होगा tan अल्फा, तो tan अल्फा क्या हो जाएगा? ई थीटा बाई ई आर. एंड इफ अगर आप ई थीटा और ई आर को डिवाइड कर दोगे तो ये आ जाएगा हाफ tan थीटा. ठीक है. तो अल्फा की वैल्यू हो जाएगी tan इनवर्स हाफ tan थीटा. So this is the general case and specific case we have already discussed. ठीक है. So in graduation and post graduation level we study in electric field due to dipole in spherical polar coordinate system. So just remember this also. ठीक है, क्लियर है? चलो, नाउ take one example here. Consider a dipole. Now, which let's write two charges plus minus 10 microcoulomb. Two charges plus minus are placed 5 mm 5 millimeter apart. Plus minus charges, they are placed 5 millimeter apart. Determine the electric field at a point at a point P on the dipole P on the dipole 15 centimeter away from its center. Away from its center. From its center O on the side of the positive charge. On the side of the positive charge. On the side of the positive charge. ठीक है? So this figure is given. Let's first see. I'm drawing this figure. You have plus 10 microcoulomb. Take it as minus 10 microcoulomb. This is minus 10 microcoulomb. Another charge is plus 10 microcoulomb. And this is the center O. This is the center O. And you have any point P. This will be the point P. And what will be the, this is 5 mm. So this is what? Two charges are placed 5 mm apart. So 2A is, here 2A is, this will be 2.5 mm. And this is also 2.5 mm. And this distance is, this is 15 centimeter. This is 15 centimeter. And what will be the, if you are taking this R is, now see, 2A is 5 mm. R is 15 centimeter. So what will be A here? A is 2.5 mm. And if you write this into centimeter, so A will be what? 0.25 centimeter. And R is 15 centimeter. So you can take R is far, far greater than A. So you can use the concept of dipole. So what will be the direction? Because this is the direction of the dipole moment. So at this point, electric field will be in the direction of the dipole. That result we have discussed. So you know the direction is in the direction of the dipole. And what will be magnitude? So magnitude of the field is given by, this will be, magnitude of field is given by E is 2p by 4 pi epsilon naught r cube. So what will be the dipole moment? Here P is, let's write the magnitude of the dipole moment. P is Q into 2a. Q is 10 to power minus 5 coulomb, because this is 10 microcoulomb. 1 microcoulomb is 10 to power minus 6 coulombs. So 10 is 10 to power minus 5, and 2a is 5 into 10 to power minus 3 meters. I'm writing in MKS units. So coulomb meter, this will be the dipole moment. So this is given by dipole moment P is 5 into 10 to power minus 8 coulomb meter. So, and you know 1 by 4 pi epsilon naught is 9 into 10 to power 9. So magnitude of the electric field is, I am writing 1 by 4 pi epsilon naught is 9 into 10 to power 9, approximately in MKS units. And 2p, this will be, this is 1 by 4 pi epsilon naught. 2 into dipole moment. So dipole moment is 5 into 10 to power minus 8 coulomb per meter. And R is, this is in centimeter. So R cube. So this will be 15 into 10 to power minus 2 meter whole cube. So what will be this value? Unit is Newton per coulomb. So this will be given by, if you calculate, this is 9 into 10 to power 9, then you have 10 to power minus 7 to, this is 15 cube into 10 to power minus 6 Newton per coulomb. And if you calculate this value, I think numerical value you have to check. So this value is 2.6 into 10 to power 5 Newton per coulomb. So it's a case of electric field due to dipole along the dipole axis. So I have used that formula, field due to dipole axis, and direction will be what? In the direction of OP. In the direction of OP. In the direction of OP. Clear? So this is A part. Now take second part where we will see in the direction in a plane perpendicular to the dipole axis. So it's just a numerical problem based on dipole case. So in B part, let's see, in B part, a point Q, you have to find a point Q, 15 centimeter, 15 centimeter away from center O on a line, passing through O, and normal to the axis of dipole, and normal to the axis of dipole as shown in figure. As shown in figure. So dipole is same dipole. So we have, this is minus 10 microcoulomb and this is of plus 10 microcoulomb. This is the center O, and you have to take a point Q. This is some point Q, and this distance is again 15 centimeter. This is again 15 centimeter. This will be 2.5 mm. This is also 2.5 mm. Dipole moment we have already calculated. So the dipole moment that we have calculated is the dipole moment P is, this is 5 into 10 to power minus 8 coulomb meter. This is coulomb meter. Coulomb meter. This is the dipole moment. But now you have to write in a plane perpendicular to the dipole axis. So this is the direction of dipole. So what will be the direction of electric field at this point? This will be opposite to the dipole axis. Is it clear? And what will be the magnitude? Magnitude of field is given by, magnitude of field is P by 4 pi epsilon naught R cube. Direction is opposite to the direction of dipole moment. So that case we have already discussed. So if you calculate this value, 1 by 4 pi epsilon naught is 9 into 10 to power 9. And P is 5 into 10 to power minus 8 coulomb. And this is 15 into 10 to power minus 2 cube. If you calculate this much Newton coulomb. So it's a matter of calculation. I think if you calculate this, you will get 1.33 into 10 to power 5 Newton per coulomb. This will be the magnitude of field at this point. Direction is opposite to the dipole moment. So must remember this case. Okay, so that is field due to dipole along the dipole axis and perpendicular to the dipole axis. Now we will see dipole in a uniform electric field. So what will happen? dipole in a uniform external field. Dipole in a uniform external field. Dipole in a uniform external field. So external field is uniform. So consider this particular dipole. Let's say this is your minus q charge, and let's see, this is the plus q charge, and I am taking this to be the center of the dipole. And let's see, this is the center of the dipole. Its dipole moment is in this direction, and there is a uniform field in this direction. There is a uniform field in this direction. Field is uniform. Uniform field is present. Field is constant. In a constant field, this dipole is placed. So what will happen? Now assume this is at some particular angle theta. So what will be force on plus q charge? Let's see. प्लस क्यू चार्ज पे क्या फोर्स होगा? ये फील्ड की डायरेक्शन में फोर्स लगेगा, प्लस क्यू चार्ज. सो दिस इज फोर्स ऑन प्लस क्यू चार्ज. ये इलेक्ट्रिक फील्ड की डायरेक्शन है, तो प्लस क्यू चार्ज पे फील्ड के डायरेक्शन में फोर्स लगेगा, और माइनस क्यू चार्ज पे फील्ड के अपोजिट डायरेक्शन में फोर्स लगेगा. यस और नो? ठीक है. But because E is constant, E magnitude of E is constant, ये यूनिफॉर्म है. So magnitude of force on plus Q is same as magnitude of force on minus Q, और ये हो जाएगा simply Q mod E. So what is the net force on the dipole? Net force on dipole. इस डाइपोल पे नेट फोर्स कितना होगा? 0. अगर डाइपोल यूनिफॉर्म फील्ड में रखा हुआ है, डाइपोल यूनिफॉर्म फील्ड में रखा हुआ है, तो उस पे नेट फोर्स 0 होगा. क्यों? क्योंकि मैग्नीट्यूड ऑफ फोर्स सेम है और डायरेक्शन अपोजिट है, तो नेट फोर्स 0 होगा. बट ये दोनों फोर्स सेम लाइन में नहीं है, दे आर सेपरेटेड बाय सम डिस्टेंस. तो अगर दो फोर्स लाइन में नहीं है, दे आर सेपरेटेड बाय सम डिस्टेंस, so they will provide torque. So there will be torque experienced by this dipole. And you know that when net force is 0, when net force is 0, torque is independent of origin. Net force 0 है, but it will experience torque dipole will experience torque tau, and it will be independent of origin. independent of origin. It will be independent of origin. Why? Because net force is zero. तो ये रिजल्ट आप याद रखो, अगर नेट फोर्स जीरो है so torque is independent of origin. So how to find this torque and what will be the direction of the torque? Torque is given by what? Torque is given by R cross F. तो अगर आप लेट्स से अबाउट द सेंटर O अगर आप देख रहे हो एंड इफ यू आर टेकिंग दिस टू बी वेक्टर R, सो इसको अगर मैं ये वेक्टर R प्लस ले लूं और इस वेक्टर को इधर मैं R माइनस ले लूं, तो R प्लस क्रॉस प्रोडक्ट दो वेक्टर का कैसे लेते हो? राइट हैंड रूल. सो यू हैव टू मूव, दिस इज R एंड दिस इज F. सो R क्रॉस F की डायरेक्शन क्या होगी? आउटवर्ड. और यहां से भी देखोगे R माइनस क्रॉस F माइनस, सो दैट इज आउटवर्ड. तो इससे आप देखोगे टॉर्क इज आउटवर्ड डायरेक्शन में है, आउटवर्ड डायरेक्शन. टॉर्क इज क्रॉस प्रोडक्ट ऑफ टू वेक्टर, और दो वेक्टर का क्रॉस प्रोडक्ट हम राइट हैंड रूल से लेते हैं. तो आप यूज योर राइट हैंड एंड मूव योर फिंगर्स फ्रॉम R टू F. जनरल रूल इज, अगर हमें किसी दो वेक्टर का क्रॉस प्रोडक्ट लेना है, इनकी डायरेक्शन क्या होगी? तो अगर ये वेक्टर A है और ये वेक्टर B है, इनके बीच का एंगल थीटा है. तो थीटा एंगल क्या होता है? जब वेक्टर्स टेल टू टेल कनेक्टेड हो. दो वेक्टर्स के बीच का एंगल क्या होता है? व्हेन दे आर कनेक्टेड टेल टू टेल. तो जो स्मॉलर एंगल होता है वो दो वेक्टर्स के बीच का एंगल होता है. तो एक एंगल थीटा है और एक एंगल है 2 पाई माई थीटा. तो स्मॉलर एंगल क्या हो गया? थीटा. तो ये एंगल बिटवीन टू वेक्टर हो गया. तो अब आप क्या करोगे? A क्रॉस B क्या होगा? राइट हैंड यूज करो और A टू B वाया स्मॉलर एंगल मूव करो. सो थंब विल गिव यू डायरेक्शन ऑफ A क्रॉस B. तो इसकी डायरेक्शन क्या होगी? अगर मैं सिर्फ डायरेक्शन बात करूं, आउटवर्ड डायरेक्शन, आउटवर्ड डायरेक्शन. और अगर मैं B क्रॉस A की डायरेक्शन लिखूं तो ये क्या हो जाएगा? इनवर्ड डायरेक्शन. ये क्या हो जाएगा? इनवर्ड डायरेक्शन. तो यहां पे देखो R क्रॉस F की डायरेक्शन आउटवर्ड होगी. और ये टॉर्क क्या करेगा? टॉर्क विल ट्राई टू अलाइन द डाइपोल इन फील्ड डायरेक्शन. टॉर्क will try to align dipole in field direction. In field direction. ठीक है. अब मैग्नीट्यूड ऑफ टॉर्क क्या होगा? व्हाट विल बी मैग्नीट्यूड ऑफ टॉर्क? इस केस में हम क्या करेंगे? जस्ट राइट डाउन दी मैग्नीट्यूड ऑफ फोर्स एंड राइट डाउन दी परपेंडिकुलर लेंथ बिटवीन दीज टू फोर्सेस. तो हमें सिर्फ ये लेंथ चाहिए. तो अगर ये टोटल एंगल थीटा है, सो दिस इज ऑल्सो थीटा. तो ये कंपोनेंट कितना हो जाएगा? 2a साइन थीटा. तो मैग्नीट्यूड हो जाएगा फोर्स Q इंटू E इंटू 2a साइन थीटा. और Q इंटू 2a क्या होगा? डाइपोल. तो इसको हम लिख सकते हैं PE साइन थीटा. ये टॉर्क हो गया. मैग्नीट्यूड ऑफ टॉर्क, डायरेक्शन इज आउटवर्ड. और इन जनरल यू कैन राइट दिस विल बी गिवन बाय सिंपली P क्रॉस E. टॉर्क क्या हो जाएगा? P क्रॉस E. इन जनरल टॉर्क इज P क्रॉस E. ठीक है. टॉर्क विल बी P क्रॉस E. तो अगर डाइपोल इलेक्ट्रिक फील्ड से या तो 0 डिग्री बना रहा है या पाई, तो टॉर्क 0 होगा. because when sin 0 is 0, sin pi is 0, तो अगर डाइपोल या तो फील्ड से अलाइंड है या अपोजिट है, दोनों केस में टॉर्क 0 होगा. If field is uniform, net force will be 0. Is it clear? So this is the case of dipole in a uniform field. Net force is 0, but it will experience torque, and torque will try to align the dipole in field direction. And when it aligns in the field direction, now torque will be also 0. And in general, it is given by simply P cross E. Is it clear? ठीक है? But when field is non-uniform, when field is non-uniform, there will be net force on the dipole also. So in non-uniform field, dipole will experience net force as well as torque about the center. So let's see. In a non-uniform field, dipole will experience net force and I'm talking about non-uniform field. Non-uniform field means field is varying. So F plus Q magnitude is different than F minus Q. तो क्या होगा? नेट फोर्स होगा. और अगर वो किसी एंगल पे है डाइपोल तो टॉर्क भी होगा. So it will experience net force and torque about the center. Now I will take one special case of the dipole when the dipole is either in the field direction or opposite direction. So what will be the net force? So let's see the case of, consider special case. I'm considering a special case. Consider a dipole. This is plus Q. I am taking this to be minus Q. And this is plus Q. So dipole is along this. This is the dipole moment is in this direction. And electric field is in this direction. Field is increasing. This is non-uniform field. Field is increasing in this direction. Field is increasing. So dipole and field direction, they are same. So torque will be 0. There is no torque experienced by the dipole. So torque will be 0. In this case, torque is 0. Since angle theta is 0 degrees. Because P and E, they are in the same direction. So sin 0 value will be 0. Now what? There will be net force because in this direction, field is continuously increasing. So what will be force experienced by minus Q charge? Force experienced by minus Q charge, this will experience force in this direction. Yes or no? And plus Q will experience force in this direction, but its magnitude will be larger. Yes or no? So it means what? There will be net force in this direction. There will be a net force on the dipole in this direction. It means when a dipole is placed in an external field and field is increasing in this direction, so there will be net force on the dipole in the direction of increasing field. But torque will be 0 because angle between these two is 0. Theta is 0, that's why torque is 0. Now, second case is, let's see, change the direction of the dipole. So what will happen? One case is when dipole is in the direction of increasing field. Another is dipole is opposite to the direction of increasing field. तो second case consider करो. अब हमने इसको प्लस क्यू कर लिया और ये माइनस क्यू कर लिया. अब डायपोल की डायरेक्शन ये हो गई. ठीक है, और ये फील्ड की डायरेक्शन है. Let's see, this is the direction of field and field is increasing in this direction. Field is increasing in this direction. Field is increasing. What will be torque on the dipole? Torque is 0 since theta is 180 degree because they are opposite. So sine 0 is 0 and sine 180 is also 0. अब क्या होगा? Just see the force. इस पे जो फोर्स की डायरेक्शन होगी वो क्या होगी? ये फोर्स की डायरेक्शन इधर होगी, F माइनस क्यू. और इस पे फोर्स क्या होगा? ये अपोजिट होगा, इसका मैग्नीट्यूड कम होगा, है कि नहीं? Magnitude is less because field is increasing. So what, this magnitude is less, this magnitude is greater. So what will be net force? So there will be net force in this direction. So it will experience a net force in the direction of decreasing field. Here it will experience net force in the direction of increasing field. Here it will experience net force in the direction of decreasing field. So that is the case of, but in general, if dipole is at some particular angle, so they will experience net force as well as net torque also. And field is non-uniform. Is it clear? So that is the case of electric dipole. So you must remember field due to electric dipole along the dipole axis, perpendicular to the dipole axis. Then we have also remember in spherical polar symmetry, and what will happen when dipole is placed in an external field. So that completes the electric dipole case. Now in next lecture, we will introduce the continuous charge distribution. We will talk about Gauss law, and then we will take some example how to find the field due to continuous charge distribution, as well as some example based on Gauss law. Clear? So in next lecture, we will discuss the continuous charges and Gauss law and their applications. Okay? So meet you tomorrow, same time. Thank you everyone. Thank you.